All right. Hello, everybody. Welcome to week number 4. This is crazy. The weeks go by so fast. All right. This week is going to be a tough one. I'm going to just put it out there. Um, some of you are going to struggle with this week's stuff. No question about it. It's not. Uh, I give you guys credit for being at the main lesson because I will tell you that people that don't come to the main lesson or don't watch it, they are not going to have any idea what they're doing on this week's assessment. All right. First thing that we have to talk about this week is a function, the sine and cosine, and we're only going to deal with the sine and cosine function this week. The sine and cosine function, they're called periodic functions. And what does that mean? It means that they repeat themselves over and over and over again. And the period of a function is the distance it takes to repeat itself. Okay? So if you take a look at this function that's down here right now, this is a sine function. It starts at 0, and we talked about that a little bit last week. And then it goes up, and then it goes to pi, and then it comes back up at 2 pi. And then, so this function goes like this. And then what it's going to do is it's going to repeat itself. It's going to repeat itself over and over and over again. That's what it means to be a periodic function, that it just keeps going, it just keeps repeating itself. So the portion that it repeats is called the period. What is the distance of it? And in this problem, the period is 2 pi, because now it's going to repeat itself. So this is 2 pi. We start at 0, we go to 2 pi, and then this would be 4 pi here, and this, if it continues again, it would be 6 pi. So every 2 pi, it just repeats itself. So the period is the distance that it takes to repeat itself. So in this problem, it's just 2 pi. That is the period. And we'll talk a little bit more about how to find a period of a function if the graph is not given. Okay? So that is what a period is. So in this problem right here, what is the period of this function? 4, right? It's just, if you take a look, if we start at 0 here, we go, okay, and then it's going to repeat itself. So the period would be 4. Now, some of the problems on the practice this week are just that easy. You're just looking at it, tell me what the period is for that. Now, none of the problems on the assessment are that easy. Sorry to say. So this is the big part of tonight's assessment, is the sine and cosine function. Okay. The sine function always starts at 0. Well, it doesn't. If we shift it left or right, it doesn't. But the sine function starts at 0. It goes up, and then it comes back down, and then it goes back up. So the period of the sine function is 2 pi, and then it's going to repeat itself. We're not going to deal too much with domain and range, but the domain of a sine or cosine function is all real numbers. You can put any number in there, you'll get a part on the graph. The range, however, is always between +1 and -1. The graph goes up 1, goes down to -1, goes up to 1, goes down to -1. So the range is always going to be between -1 and 1. Same thing with the cosine function. Now the cosine function starts at 1, then it goes down, comes back up, and it goes back to +1, but it goes down, starts at +1, goes down to -1. So cosine function, if you just moved the sine function over, okay, if I just started right here, this would be the cosine function, wouldn't it? So the sine and cosine functions, they're just shifted 90 degrees, and you would get the other function. It's just one of those things that it is. They're basically the same function, just shifted over 90 degrees. Now we're going to talk about shifting the sine and cosine function. Now hopefully you guys watched the lesson tutorial, because if you did not, you might skip a few things. Well, the graph is, if you think about this, this is 90 degrees here. This is 180 degrees here. I always talk about graphs that are positive and negative. Well, I guess you would have to shift backwards 90 degrees, because then, so if you shift backwards 90 degrees, look at, you have the sine function. 180 degrees is pi, right? Exactly. I don't usually use the radian measures. I could have said, okay, if you shift the cosine negative pi over 2, you would get the sine graph. Yeah, that's true. Okay, but I don't usually talk radian measure. I always talk degree measures. And we'll talk more about that in just a bit. So now there's 3 ways that we can shift a graph: the amplitude, the just shifting it vertically up and down, and shifting it left and right. Just like any other graph, we can do the same thing with sine graphs. Okay, so let's talk about how we shift them. Well, I guess we have to talk about the period first. The period of a graph. So if I gave you this function right here, sine of 2x, and I asked you, what is the period of that graph? The number in front of the x is called the b value. Okay? Why do they call it the b value? I have no idea why they call it b value, but that's the b value. Okay? How do you find the period of this graph? Well, you plug it into this formula. Period is equal to 2 pi over the absolute value of b. So basically what that says is just make it positive. Okay? So my b value is 2. So if I put 2 in here, the period of this graph, so the period is equal to 2 pi over 2, cross that out. The period of this graph is pi. Okay. So if I was going to graph this function right here, if I was going to graph this, this is what it would look like. Usually we go like this. Whenever I do a graph, I usually say, okay, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Or if I was doing it using radian measures, I'd say, okay, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. A normal, so this is 1, this is negative 1. So a normal sine graph would look like this. It would start at 0. I'm going to put a few values in here. So it would start at 0. It would go up, down, and then it would repeat itself. Okay? That's a normal sine graph. This is the graph of sine of x. But in this problem, if I wanted to graph the sine of 2x, the period is pi. Oh, what does that mean? Well, that means all of, let's see, what color do I want to use here? I'll use black. So all of this, the whole sine graph is shrunk. It's shrunk. So now the whole sine graph has to be between here. So now I would do this. I always break it into 4 parts. So it starts at 0, goes up to here, 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 and here. So it's going to go like this. So now my graph is going to look something like this. See how it's, if I could just take the left or the right hand side and just scoot it in, that would be my new graph. This is the sine, the black one is the sine of 2x. I just graphed because it has a period of pi. So it's just squished, right? Exactly. So that is what the period does. And so the first thing you have to do when you graph one of these, there's 3 things you want to do when you graph these things. You want to know what the amplitude is, you want to know what the period is, and you want to know what the vertical shift is. Okay? So we're going to talk about the vertical shift next. So if I gave you this graph, let's say I gave you the sine of x plus 3. What do you think that plus 3 is going to do to this graph? It's going to shift it up 3 units, right? So this whole thing, it's going to look exact. So I'm doing the sine of x plus 3. So this whole thing, so I'm going to go 1, 2, 3. So now this is going to be the middle of my graph, okay? But it's going to look exactly the same. It's going to go up, down, and back up. So I'm just, that plus 3 behind there just shifts it up 3 units. Just like all of our graphs, the number behind it's going to shift it up or down. This number inside here is going to change the period. Okay? Now, if I put a number in front of here, what does that do? That changes the amplitude. What is the amplitude of a normal sine function? It's just 1. Vertical, not sure we're going to talk about vertical stretch or shrink. That's just the period. Vertical shift up and down, but we're going to also talk about shifting left and right. Well, we're not into that just yet. But this number in front of here is called the amplitude. The normal sine graph has an amplitude of 1. It goes up 1, it goes down 1. Now, if you put a 3 in front of there, that means the amplitude is 3 now. So it goes up to 3, back down to -3, and back up. So now my amplitude, how high does it go? Goes up 3, goes down 3. So that number in front is called the amplitude. All right, so there's a lot of stuff here. Yep. So now in this graph here, let's do 2 graphs. Let's do, in this problem, let's do y is equal to 3 sine of x, and then y is equal to 3 sine of 2x. Okay, so in this problem, when I do a problem like this, the first thing I always do is I always write down what is the period, what is the amplitude, what is the vertical shift up or down, and then we're going to talk about shifting left and right, but we're not there yet. So I'm doing this one right here. What is the period? Period is not 2. Okay. Okay. Remember, to find the period, yes, it's 2 pi, because the period is equal to 2 pi over b. Well, my b value in this problem is 1, right? Because it's a number in front of x. So if I put 1 in here, my period is 2 pi. 2 pi. Done. Okay? Does everybody understand that? How to find the period? Okay. What's the amplitude in this problem? 3, right? Am I shifting this graph up or down anything? Is it going to be shifted up or down? Nope. So 0. So if I was going to graph this thing, first thing I do is I look, okay, period, 2 pi. So it's going to start here, and it's a sine function, so it's going to start at 0. It's going to go to 2 pi. My amplitude is 3. So this graph is going to go up 1, 2, 3. So at pi over 2, it's going to be at 3. Then it's going to be at 0. Then it's going to go down 3. So it's going to be here. And then it's going to go to here. So my graph is going to go up 3, back down to -3, and then back up. So that is my normal sine graph, just with an amplitude of 3. Now, if I was going to graph this one right here, 3 sine of 2x, okay, what is the amplitude? 3. What is the period of this graph? Okay, yes, it's just pi. Is it going to be shifted up or down? Nope, none. So now this is my period. So I put a little slash there. And then I want to break my graph into 4 places. Anytime I graph sine or cosine, I always break it up into 4. So this is 1, 2, 3, 4. So at the first one, so it's going to start at 0. It's going to go all the way up to 3. It's going to go back to 0. It's going to go down to -3. And then it's going to go back to 0. So my graph is going to look like this. It's going to go up, down, back up. And that is the graph of y is equal to 3 sine of 2x. It's just scrunched in. Does that make sense? It is a squish, and we should call it a squish. Okay. not too bad yet, right? It's not that bad. All right, so let's take a look. Yeah. All right, so this is a cosine graph, okay? What is the amplitude in this problem? What's my amplitude? 4. Agreed, that is 4. What is the period? Pi. Absolutely. Good. So now this is a cosine graph. So I know cosine starts at 1. Well, in this time, I'm going to go up 1, 2, 3, 4. And then since the period is only 4, so I'm going to break this into 4 distinct equal intervals. So it's going to start up here. Let me do this in red. So it's going to start up here. It's going to hit here. Then it's going to go down 4. And it's going to hit here. And then it's going to go back up to 4. So my cosine graph is going to look like this. It's going to go down, and it's going to turn up, and it's going to go like this. Not exactly the most perfect. Now, does anybody have Desmos on their calculator or on their keyboard? You can check your answers just by going to Desmos, type in 4 cosine 2x. Make sure your graph is in degree mode. I suppose it really doesn't matter. And then you'll see that it's, well, when you do Desmos, it's gonna go back, it's gonna be like that. It's gonna keep going, but you should be able to check your answers real quick to see if it looks right. Okay, so finding the amplitude and the period, not a big deal. All right, and being able to shift it up and down, not a big deal either, right? So this is where it gets really hard. All right. Yeah, all you have to do is one cycle. Yep. All you have to do is just one. You don't have to keep drawing it out. Makes no difference. So now we're going to talk about moving left and right. If I gave you the graph of y is equal to x squared, we know that the graph looks something like this. And if I asked you to graph y is equal to x minus 2 squared, we know that that's going to shift it 2 places to the right, right? So 1, 2, it's going to look exactly the same. It just shifted 2 places to the right. Well, this is exactly the same thing. If you have something inside, so if I gave you something like the sine of x plus pi over 2, and I asked you to graph that, okay? All right, so what do I need to know? I need to know the amplitude. I need to know the period. I need to know if it's a vertical shift up or down, so if it's going to go up or down. I'll just put up or down there, and then left, right. All right, so in this problem, what is the amplitude? 1. What is the period? 2 pi. That's exactly right. Does it move up or down at all? Nope. How far left or right is it going to be shifted? Or which direction is it going to be shifted? Left, 2 pi, or pi over 2. Left, pi over 2, or 90 degrees, right? So if I was going to graph this out, okay, this is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. This is negative pi over 2. And I'm going backwards. The sine function starts at 0. So that means I am going to start at 0 here. What is the period? The period's 2 pi. Well, I'm not going to go way over to here because this, if I start here and I go to here, that's 2 pi, right? Because 90, 180, 270, 360. This is 2 pi. So I start here. My amplitude is 1. So I'm going to go up to 1, down, down, back up. So here's my graph. Boom. That's it. It's basically a cosine graph. You're absolutely, well, because cosine graph would start here, go down, but then it would continue back up to here, right? But you're right. It's a cosine graph, exactly. So if you were doing Desmos and you wanted to check yourself, okay, put in this function and put in the cosine of x. They should be the exact same graph. They should go right on top of each other, right? Pretty cool. Pretty cool. Some of you are like, that guy's crazy. That's not pretty cool. That's crazy stuff. All right. Now, that's not the hardest part, okay? This is the hardest part. And I'm going to say that you never want to deal with this here. You never want to deal with a number inside because it really messes everything up. It really messes it up. So what you want to do is you want to pull that b on the outside. So if I gave you something like, that's not what I wanted. I just want a clean sheet of paper. Okay, let's just work down here. So if I gave you something like the sine of 2x plus 2 pi, what is the amplitude? What is the period? Left or right? Now, you guys are going to get this wrong pretty quickly, I think. Okay, what is the amplitude? Pi. Nah, 1. What is the period? And somebody said the period was pi. Okay. How far left and right do you, or how far left or right do you move? And you can't do that when it's in this form. Okay. You want to pull, you want to get this out of here. You never want a number in front of the x value when there's something else in there. So what I would suggest is I would say factor out of 2. So then you'd rewrite it like this. Now, okay, that's my b value, and this is how far I'm going to shift. So I'm going to shift. The amplitude is not 2 because the amplitude is the number in front here. So the amplitude is just 1. The period is pi because if I put this into my formula, 2 pi over 2, it is just pi. But now it's like, oh, I'm going to shift left pi units. So it's going to go left pi units. Okay? So that is the one thing that usually messes most kids up, is if there's a number in here and something here, you want to factor that out. So that's your b value, and this is how far it's moving left or right. That is the one thing that really messes kids up. That is it. So if you ever have something like this, just factor that number out, and the number in front of the parentheses is going to be your b value, and then this is going to be how far you're going to shift left or right. Yes. Okay. All right. Okay, so there's only one more graph that I want to do. So if I was going to graph this out, okay? Now, could I write this problem like this? Could I put a 1 in front of here? Yep, okay. All right, so what is my amplitude? My amplitude is 3. I agree. What is the period? 2 pi. Agreed. Phase shift. Okay, that's left or right. So how far am I going to shift left or right? Left pi units. I agree. Left pi units. Vertical shift. Am I going to go up or down? Up 2? No. Down 2. This -2 is telling me that I'm going to shift that graph down 2. All right. So I'm going to count. This is 1, 2, 3, 4, -1, -2, -3, -4. Now this is going to be a really tough graph because this now is the x-axis because it shifted down 2. So now this is the x-axis. So I don't look at this one anymore. I just look at this one because that means I just shifted down 2 places. Okay? So now, what's my amplitude? It's 3, but the period is 2 pi, but I'm gonna shift pi units to the left. So this is where I'm going to start. Well, tell you the truth, I'm gonna start here. And then I'm gonna go, and this is a sine function. So I'm gonna break this into 4 equal intervals. So 1, 2, 3, 4. I'm going to go up 3. So I start here at 0. So I'm going to do that in blue. So I'm going to start here in blue, and then my first unit I'm going to go up 3, 1. Oh, I think, yeah. So 1, 2, 3, and then I'm going to go down. Then I'm going to go down 3, 1, 2, 3, and I'm going to go up. So my graph is going to look like this. Why did I move the x-axis down? Because this right here tells me that I'm shifting the whole graph down 2 units. So basically, I'm just shifting that whole x-axis down 2 units, and then I'm going to start from then. That's what I'm going to use as my x-axis. Okay, that's why I moved that whole x-axis down. Now, does somebody have Desmos? Can you plug in 3 sine of x plus pi minus 2? And see if our graph is where it's supposed to be. Allison, I'm not exactly sure what you mean by, but does that mean the line is 2 below the line? It is 2 below the line. That's why when I do my amplitude, my amplitude is 3, so that means I have to go up 3. So 1, 2, 3. That's why I went up to +1. But that -2 just means, now I could have graphed without shifting down -2 and then just moved every point down 2 places. That I could have done, I could have did that, but to me, just shifting the x-axis down 2 units. Now, if this was +2, if this was a +2, I would have moved that up to +2, and then I would have, did my graph from there. I would have, then it would have gone up, and then comes back down and then goes back up. So if it was a +2, it would have just shifted everything up 2 units. So it basically is just shifting that x-axis. Yeah, exactly. That's why graphing calculators are so amazing that it's like, oh, this really helps me to see if this is correct or not. The period is just a simple function. Period is just 2 pi over b. So if you know what your b value is, and in this problem the b value is 1, so you just put 1 in there. So my period is 2 pi. And that, now I could have said that's 360. I mean, but usually when they do the graphs, they'll do it in radian modes. I mean, that's neither here nor there. Okay, I'm taking a look at the time, and we have to get to our practice problems, or else you guys are going to be mad at me because we didn't go through our practice problems and you don't know what they are, the answers are. So let's get to the practice problems and see if we have any questions on those. So I have to go into my collections here. I got to get the right one out here for you guys. Let's see here. So view dashboard. I'm just getting the. Okay, so this is the link to it. And I know some kids, they don't use the link, which is perfectly fine. So what I'm going to do is I'm going to share my screen with you guys so you can see the problems. Algebra 2, Desmos. Okay, I think that one's it. All right. So here's problem number one. Problem number one, all it asks, okay, it says use transformations to graph the function y is equal to 5 sine of x. Well, what does the 5 do to that graph? What does that 5 going to do to the whole graph? It's the amplitude. It's just going to make the sine graph go up 5 units. So graph number one, is that even the sine graph? Or letter A, is that the sine graph? No, that's cosine graph. So I can cross that off right away. It's like, oh, that can't be right. That's a cosine graph. This one is shifting everything up. That can't be right. That can't be right. It's shifted up. So this one, it's a sine graph. It goes up to 5, back down. Oh, that to me looks like the sine of 5x. Yes. Oh, that right. Yeah. Everybody only has those. Yes, we talked about this before. Yeah, got it. But you do have all three graphs are there, right? The C and D are there. You just only have A and B as your choices. So B is fine. So yeah, all right. Yeah, so hopefully you didn't pick C and D for an answer because then you wouldn't have been able to select it. All right. Problem number 2. It says, which function has an amplitude of 2 and a period of pi? Okay. So not a whole lot of work here, right? If you understand the concept here, an amplitude of 2 and a period of pi, A is the only choice that would work, right? Because C and D, the amplitude is 1/2. Part B, can anybody tell me what the period is for part B? What is the period for 2 cosine pi x? What would the period be of that function? It would be 2. Yeah, because you would say, okay, how do I find the period? The period is found by doing 2 pi over b. Well, my b value here is pi, so if I put pi in here, those are just going to cross out. My period would end up being 2. No, that's not what they asked for. They asked for the period of pi. So the answer is letter A, correct? So that should be my answer. The answer should be letter A. All right, question number 3, and then I'll take some questions here. It says, what is the period of the function y is equal to -3 cosine 1/4 x? A negative amplitude, it really doesn't make any difference. That is also an absolute value. A negative amplitude, okay, I didn't tell you how to do that. Okay, so let's just answer this question, and then we'll talk about negative in front of the amplitude. Okay, so the answer, again, I'm going to do period is equal to 2 pi over b. My b value is 1/4. Oh, okay, I put 1/4 in here. Uh-oh, that is a complex fraction. So I'm just going to flip that over. 4 over 1, that gives me 8 pi. Now, somebody asked about that negative in front. If I asked you to graph, okay, so if I asked you to graph this function, -1 sine of x. Okay, here is the normal sine graph. It goes up to 1, goes down to 1. So it goes up here, then it comes down, and it goes back up. If there's a negative in front, it does exactly the opposite. It goes this way. That's what the negative does. It just flips it over. Just like if we had, remember, if we had y is equal to x squared, we would graph that out and it would look like this. And if we had y is equal to -x squared, that would be this graph here. Just flips it over. Same concept on that negative in front. Yes, we're right in. Don't I need some of these things in here though? For Dean H. Yes. All right. Got to get a little bit of that, what is that, chemistry in there or biology? All right. Before I go on, any questions on any of the first three problems that we've done? Okay. All right. So let's go to the next one. Number 4. It says, what is the period of the graph whose equation is a 3 cosine of x? Now, or 3 cosine 2x. Now remember this answer because I think problem number 6 is exactly the same. Yes, I did do the practice this week. Usually I don't do it. All right. So the period of this graph is number 1, isn't it? Isn't it 180? Pi is the same thing as 180. So I would assume that the answer is 1. Allison asked for you to go back to question number 1. Sure, I can do that. I didn't see that. Sorry about that, Allison. Okay. Do you have a question on number 1? Question number 1 is B. Yes, it is B. Allison, did you have a question on that? Sure. Now, if I look at this problem, it asks me to find the 5 sine of x, right? Okay, so the number in front is the amplitude. It's 5. Sine graph always starts at 0. So I know I'm looking at a graph that starts at 0, goes up to 5, comes back down, goes down to 5, and comes back up. So I'm looking for a function that looks like this. Okay, now, so I look over here and it's like, okay, this one is a cosine graph because it starts up at the top. So that's a cosine graph. This one starts at 0. So yes, and it goes up to 5, down to 5. So this is my graph. Now this one is shifted up 5. Now this graph here would be the sine of x plus 5. So that would be that graph there. So there's a huge difference in what you're looking at. Okay, does that help out? All right. Let's see here. So we are on, I think it was number 4. Okay, and we said that number 4 was 180 degrees because it's just pi for my answer, and pi is 180. All right, number 5. It says, what is the equation of the accompanying graph? Okay, so now this is probably one of the hardest types of problems that are on the assessment this week. Being able to graph out or being able to write an equation of a graph. Okay, so what do I do? What are my steps? First step, what is the amplitude? Second step, what is the period? Third step, is it shifted up or down or left or right? Okay, so I would, just by looking at the answers, I know it's not. Okay, so the first thing I do is I ask myself, is it cosine or sine? How do I know the difference? Where does it start? If it starts above, it's cosine. If it starts at 0, it's sine, right? So this is a cosine graph, right? So right away, I'm going to put down cosine. Then I'm going to find the amplitude. Well, this looks like +1. This looks like -1. Amplitude is 1. Okay, now, if this is a cosine graph, right here at 2 pi, that's only halfway done, right? We only see half of the cosine graph. So the period must be 4 pi, right? Because I only see half of the cosine graph. That means the period has to be 4 pi because the half of the cosine graph that I see only goes to 2 pi. So if I do another half, it should go to 4 pi. So now, what's my b value? That's the question, because remember, my equation is going to be cosine of bx. The b value. What is my b value? What is the b value? 1/2. Okay, and how did you find that? Well, if I was going to do it, I go back here, I go period is equal to 2 pi over b. I know what the period is. It's 4 pi, so I put that in there. I put 4 pi there is equal to 2 pi over b. I want to solve for b, so I'm going to bring b up here, cross that out. I'm going to divide through by 4 pi. So b is equal to 2 over 4, which is 1/2. Boom! I just came up with my b value. So now I can write my equation. I know it's cosine. I know the amplitude is 1. So it's just going to be 1 cosine of 1/2 x. Done. That is it. Samantha, I'm not exactly sure what you mean by 4 divided by d. Oh, okay. All right. Got it. Okay, so the answer is letter 4 or D. I don't know on my practice if I think I have the numbers down there. I think I have 1, 2, 3, 4 in the answer blanks. I'm not 100% sure. I could have A, B, C, D. It says 1, 2, 3, 4. Okay, awesome. All right. So pretty, interesting. No question about it. A lot of stuff here. All right, let's try number 6. I think number 6 is exactly the same as number 4, if I'm not mistaken. So my answer should be 1 again, right? Sorry about that for putting the same thing in there. Again, I tried to change the question yesterday, could not do it. Somebody had already opened the practice, so it's like, yeah. That's all right. All right. Number 7. Number 7, it says, which function has a period of 2? Okay, so now it's just looking at a graph, figuring out what the period is of the function. Letter C starts down here, goes to 2, and starts all over again. I agree. Letter C is the correct answer. Very nice. Okay. Let's try another one. Number 8. Which function has a period of 5? What about 6? 6 was the exact same problem as number 4. They're the same problem. Number 4 and 6 are the exact same problem. So number 4 and 6 should be 1 as the answer. Yeah, it was the same. It was the same thing. All right. What's 7 then? You're letter C. Number 7 was just which one had a period of 2. So in this problem, starts here, 2 is here, function goes up, comes down, goes up, comes down, goes up, comes down. So the period is 2 there. In this problem, you'd have to start way over here and go way over here before it repeats. That looks like a period of 6. This one here looks like the period would be 4. And this one here, where is it? Start and stop. So I always try to find where it crosses. That looks like maybe 8. So letter C is period of 2. Number 8, which one of the functions has a period of 5? Letter B. Let's see here. So if I start, oops, I'm on the wrong slide here. So if I start here, go to here, 1, 2, 3, 4, 5, and then it's going to repeat itself. I agree. That would be that graph. Now, I will tell you that the hardest problem on the assessment this week is being able to write an equation of a graph. Okay. So what we're going to do right now, and this is not the question for number 8, but we're going to take letter B and we're going to write the equation for that thing. Okay? So what I want, and if you can write the equation for that, you're going to be pretty well set for, oh, this one's pretty hard because it looks like it's hard to figure out. Oh, no, that's up to. Okay. So what I want you to do is I want you to write the equation for that thing. You can write an equation for that. You're going to be, you'll have no problems with number 3 this week on the assessment. And that's the one that asks you to write an equation of a graphed out thing. Okay. So what would that be? Well, amplitude is 1. Are you sure the amplitude is 1? Now, I like where you're starting, Samantha. You're looking for the amplitude, the period, and all that kind of stuff. But I'm not sure the amplitude is 1 in this problem. It looks like it's 2, doesn't it? It looks like it goes up to 2, down 2. So the amplitude is 2. Okay. The period, we already said what the period was, didn't we? We said the period was 5, didn't we? Okay. Is it a sine or cosine graph? This is a sine graph, right? Because it starts at 0. Okay. So sine graph. So now it's not shifted anywhere left and right. It's not shifted up or down. So I can write my equation. The only problem is I don't know what my b value is, right? Because when I write my equation, it's going to be 2 sine of bx. I don't know what b is. I'll remember to find b, the period is equal to 2 pi over b. I want to find b. I know what the period is. It's 5. So I'm just going to put 5 is equal to 2 pi over b. I'm going to bring the b up here. I'm going to bring the 5 down here. Okay, I'm just solving for b. So b is equal to 2 pi over 5. So my equation, the equation for this graph, is 2 sine 2 pi over 5 x. Done. So if they ask me to write an equation for that, that would be my equation. How do you determine if it's sine or cosine graph? Where it starts, right? If it starts at 0, sine graph. If it starts at 1 or 2, cosine. Now, oh, do I want to mess with your heads here? Oh boy. Okay, I won't. I won't. I won't. I sorry. I don't. It was just because if I asked you to write this equation, so we wrote it as a sine equation, right? But could I ask you to write it as a cosine graph? And the answer is yeah, I could have. I could have said, hey, write it as a cosine graph. Yeah, then you're just shifting it. If I asked you to write it as a cosine graph, a cosine equation, then you would just do 2 cosine, oops, sorry. You do 2 cosine of 2 pi over 5 x, and then how far did I shift it? Cosine would start over here, wouldn't it? So it just shifted what? How many places to the right? So that would be, well, I would have to write it this way: 2 cosine 2 pi over 5 x. I'm moving it to the right, so it would be subtraction, right? Subtract 1.5 or whatever that is. I don't know what that is. It's not a really nice graph, but I could have asked you to write it as a cosine graph. Yeah, because you're just shifting it then. You're just shifting a sine graph to be a cosine graph. Once you understand that, then it's like, then all of this stuff just comes together. It's like, oh, it's just a sine and cosine graph is just shifted over how many units. And in this problem, it looks like 1.5, right? Close to that, but you really couldn't actually write the graph for it, but that's what it means. If it asks you to write it as a sine graph, pretty easy. It starts at 0. If it asks you to write it as a cosine graph, it's like, oh, okay, how far do I have to shift over to make it a cosine graph? But forget about that. That's a little bit above your pay grade right now. All right. All right. Let's go to number 9. What is the amplitude of this problem? Exactly right. The amplitude for this problem is 3, right? It's the number in front. That is your amplitude. Correct. Yes. And the last problem on the practice for this week, it says y is equal to 5 cosine of 1/4 x. Find the amplitude. Oh no, Mr. Shanklin, you made it too easy at the end. It's 5, right? It's the number out in front. Now my suggestion to you guys, okay, and this is just a suggestion, is go in, put your answers in for the practice. You'll get 100% on the practice. Then I would try the assessment. I would do the problems that I could. Now the first 2 are pretty easy. 3 and 4 get a little bit tougher. If you need some help, then on Wednesday, come to the help session and we'll go through different types of problems just like it. Okay, so give it a shot. As I said, numbers 1 and 2, I don't think you'll have any problems with on the assessment this week. 3 and 4, yeah, 3 and 4 are the tough ones. I will record the help session if somebody reminds me to record it. Okay, like the last couple of weeks, there's been nobody there. So or one person would come in and ask one question. It's not worth putting on the recording if you're not going to, I'm just going to sit there and watch me just sit there and do my homework. Okay, so, but if there's other kids there, sure, absolutely, recording's perfect. Recording silence for an hour probably would not be exciting to watch. But that would be my suggestion. And that's how I would do it every week. That is, you guys got it made because, oh, darn it, I didn't take attendance. I'm sorry. Guys, hold on 1 second. I forgot to take attendance this week, and I do like to have that down. I should have did it when you guys were working on a problem. I apologize. Sometimes I get too excited doing my math that I forget to take attendance here. All right, so this is week number 4. Right. And why do I take attendance? I mean, there's no, I don't have to take it. It's just at the end of the year, I usually get students, oh, but I'm failing the class, and I like to be able to look and see, oh, well, you haven't come to any of the help sessions or the main lessons, so kind of probably tells why you're not passing the class. I don't say it like that, but it's the kind of thing I think about. It's like students that usually come to the assessments usually do well. I mean, it's just usually how it is. Okay. No, no. If the number in front, let me go through that again. I did try that one time. So if I gave you the graph of sine, let's say I gave you the graph of sine of 2x, and I asked you to graph that. Okay, that's a sine graph, has an amplitude of 2. So 1, 2. So it would go like this, go down to 2, and back up. So that would be the 2 sine of x. Now, if it was a negative in front, the amplitude is still 2. The only difference is, and this is where we get that, it just goes back, it goes down 2, then up, and then up 2, and then back down. So the amplitude is still 2. It just goes the opposite direction. That's all the negative does. It just makes it go the opposite direction. No, the amplitude is always positive. Your amplitude is always positive because it's a distance. So the amplitude is positive. You would say, if they asked you for the amplitude there, you should just say 2. Would I mark it wrong if you put negative 2? No, I would not mark that wrong, but it is 2. The amplitude is 2. It's the distance from the x-axis to the highest point or lowest point. So it would be 2. But as I said, I would not mark it wrong if you put negative 2 there. All right. Hopefully we'll see some of you on Wednesday for the help session. Well, no, we don't. Wednesday's supposed to be 45 degrees. But yes, we will. Even though it's 45 degrees, I will make time for the help session. You guys have a great one. Bye. Okay, go ahead. Nicholas, what's your question? Oh, there is a, yes, there is a unit assessment. So there should be 3 things to do this week, I believe. There is a unit. You're absolutely correct. Let me jump in there real quick. I think there's three assessments. 2 of them are multiple choice. 1 of them is the free response. But I do think you're absolutely correct. There is a unit. There is a unit. We're done with the unit after this week. So yes, I think there is 4A, 4B, and 4C. Yep, there is a unit. You are absolutely correct. There is a 4C there. Yeah. Nope. Yep, we're done with the unit this week. So there's a unit assessment there. Good catch. Thank you. You too. Bye.